All right, so this video is going to cover compound inequalities. Compound inequalities, just like a compound sentence. A compound sentence is a sentence where you join two ideas together. So it could be, I like cake, comma, and I like ice cream. That's a compound sentence because you're joining the idea that you like cake with the idea that you like ice cream. And in this case, because it's the word and, that means both have to be true. I like cake and I like ice cream. If you use the word or, one could be true or the other could be true. So if I said I like cake or I like ice cream, I don't necessarily have to be liking both. So a compound inequality is very similar to a compound sentence. And compound inequalities can be joined together. So if I have the compound inequality that x has to be a number greater than 2 and it has to be a number that's less than 6, I can write that as a single inequality. X is greater than 2. I just flipped it around. And x is less than 6. On a number line, 2, 3, 4, 5, 6 are numbers that would apply to this inequality because the number 3, for instance, is bigger than 2 and it's also less than 6. Same with the number 4, same with the number 5. If I think of the number 7, though, even though 7 is greater than 2, it is not also less than 6. So an and inequality, when you graph it, has an open circle because of the less than symbol on 2, an open circle because of the less than symbol of 6, and it's a line only connecting the numbers in between. We wouldn't have any of the line go out here because numbers like 8, 9, 10, and 11 are not less than 6. Only these numbers are solutions. I like to say it kind of looks like a barbell, like those things you pick up and put down at the gym. So the graph should look like that. If it had been equal to symbols, please note that we would close the circles. For this one, we never make it one inequality when it's or. When it's or, it's saying either you can be less than 2. So numbers that are less than 2 would be 0 and 1. Or you could be greater than 6. So numbers that are greater than 6 would be numbers like 7, 8, or 9. So two things, only one of them has to be true when you use the word or. So numbers that are less than 2 are over here. So you can either be a number like 0 or 1, or numbers that are greater than 6 are over here, 7, 8, 9. One of these two lines can be your solution when you use the word or. So I always say it looks like two oars in a boat, like row, row, row your boat. So solving compound inequalities follow the same steps. For and inequalities, you're going to have to perform the same operation to all three sides. So like here, our and inequality has 1, 2, 3 sides. So anything you do to the 2 has to be done to the x and has to be done to the 6. For or inequalities, you have two separate ones. You're just going to solve them separately. And as always with inequalities, when we multiply or divide by a negative, we flip the inequality symbol. So here's an example of and inequality. This is an and inequality. I can tell because it's joined into one compound inequality. So I'm trying to isolate x. I need to get this x in the middle by itself. So I need to get rid of the minus 1 by adding 1 to the 8 and to the 11. So we are going to get 9 is less than 3x is less than 12. And I'm still trying to isolate x, so I'm going to divide by the 3. And I'm going to get that 3 is less than x, which is less than 4. So only numbers between 3 and 4 are going to work here. With compound inequalities, it's enough to just write your two important numbers. Both 3 and 4 are getting open circles, and we're joining it in between with a line because this is always what an and graph will look like. For this next one, I need to get rid of the minus 10 by adding 10 to all three sides. So positive 1 is less than negative x, which is less than positive 5. And I need to get rid of the negative sign by dividing by negative 1. So I get negative 1 is greater than x, which is greater than negative 5. I flipped all my inequality symbols because I divided by a negative. So I reverse them due to the division of negative 1. We may want to flip this around so that the smaller number is on the back end. So if we do that, we flip the entire equation, including the directions that the inequality symbols are facing. So negative 5 is our low number, negative 1 is our highest number. We can only have numbers that are between negative 5 and 1 because we can only have numbers that are bigger than negative 5 while also being smaller than negative 1. So numbers like negative 4, negative 3, negative 2 are all solutions here. For OR compound inequalities, we're just going to solve each inequality separately. So I'm going to start by clearing out my fraction, multiplying the whole equation by 2, subtracting 2, and we get our first inequality is that x has to be less than 10. My second inequality, I'm going to subtract the 5, so I get that my second inequality is that x has to be greater than 14. So either x is going to be less than 10, the numbers less than 10 are over here, or the numbers are going to be bigger than 14, which are over here. My graph ends up looking like two oars in a boat. For this one, I'm going to solve this inequality first by clearing the fraction. So w minus 13 is less than or equal to negative 12. I'm going to add 13 to both sides and get w is greater than or equal to 1. I'm going to times 2 to both sides to clear the fraction again. So w plus 17 is less than or equals to 16. So again, I have two separate inequalities. Either w is less than negative 1. Close circle this time. The last ones have been open, but this is equal to. So I close my circle. Numbers that are greater than 1 or less than negative 1 will be solutions to this compound inequality. So if I'm given a graph and need to write an inequality, I'm going to decide if it's an and or. Based on the direction of the arrows, it's an or compound inequality. So two options. X could be, if I'm looking at this inequality, closed circle with the arrow pointing to the left, x is less than or equal to negative 8, or open circle and 0, pointing to the right, to the higher numbers, x is greater than 0. Because it was an open circle, I don't put the line. This shape looks like a dumbbell, so it's and inequalities have the lowest number on the left and then the highest number on the right. So negative 9 less than x less than negative 2. Just keep in mind that this could also be written separately. The separately way would be that x is greater than negative 9. That's what this part of the inequality says, just written with the x on the other side. And x is less than negative 2. So you can split apart an and inequality to make it look like an or. We just typically write it in this format. So there are some special cases. You can get all real numbers and you can get no solutions. The titles are switched on these. So this one should be the no solutions option because no solutions only happen when it's an and inequality. And this one should say all real numbers. All real numbers only happens if it's an or inequality. So if I solve this one, I get that x has to be, or excuse me, v has to be greater than 1 and also be less than 3. If I try to be greater than 1, oh, sorry, that's supposed to be -3. If I try to be greater than 1 and less than -3, how can I be a number that's smaller than 3 and also bigger than 1? This graph, if you notice, kind of looks like an or graph. So if you have an and inequality that looks like an or, that is no solutions because it's physically impossible to be smaller than -3 and bigger than 1. For this one, x is greater than 4, or this should be +7. Sorry. Actually, sorry, not +7. That should actually be the number 12. Sorry, this should actually be the number 13. There we go. If I solve that inequality, I would add 1 and divide by 2 to both sides. So in this case, I have a number that's either bigger than 4 or less than 7. So what you might notice with this graph is that these are overlapping in a way. This circle overlaps here. This line overlaps here. Every single number falls on this number line. If you're greater than 4 or less than 7, that's any number possible, all real numbers. So if you get an OR graph that overlaps like this, has two arrows overlapping, the answer is going to be all real numbers. So a no solution will always be an and inequality, and all real numbers will always come from an or inequality. That's the important thing to know about the special cases.